Next, I want to talk about about mapping the geography of soils. So mapping, or in other words, soil geography. And one thing what we do as geographers is we map things out. Soils in the United States are mapped out by the U.S. Department of Agriculture. They have a department called the Natural Resource Conservation Service. They were developed during the Dust Bowl era, when a lot of our natural resources like soil were blowing away. The government wanted to map out where these soils were and understand them better. And one thing they do is they create soil maps. Historically, these were paper maps. Now they're GIS, or Geographic Information System maps, of soils in the United States. These have a lot of there's a lot of complex data that goes with each of the soil boundaries. They do both general maps of the United States as a whole, and also very detailed maps at the local level. Let's take a little look at that. First off, a little term here. A pedon is the basic and smallest unit of soil. So it's really like a sample collected in the field. We'll include a video where people are actually collecting field samples of soils. And so that's really the basis of the mapping, is these field individual collections, sort of the smallest unit of soil that you can measure, a field sample essentially. That field sample is kind of part of using the field samples, we can kind of map out an area of relatively homogeneous soils. And then those can be added to other homogeneous soils across a landscape. So here what we're doing is we're taking a landscape, we're kind of mapping out where the soils are similar, and we know they're similar because of the samples that are taken. Now, historically, these have been done using books that are soil surveys. Nowadays, a lot of the information is also online and digital format, but this is a physical book, the soil survey of this particular area. And in those books, they would actually have paper maps. These were done by people in the field collecting soil samples and using aerial photography to map out the general distribution of different classes of soil. Nowadays, we have a lot more digital resources. One that we'll use in class is put together by UC Davis, where they take the map soil information in GIS form and combine it with online mapping. And that gives you access to a map, but also to a lot of information about the individual soil. Let me just give you an example of some of that data, the soil GIS data, and how it might relate to other themes. So this is taking GIS data for soil, some of the soil mapping that's been done around Central California, and looking at one factor, how well it can drain water. The areas that are greener, the water can have more sand, the water can drain very well. And the areas in red here, in the middle of the valley, are poorly drained, and typically these are the soils that have more clay, because the water doesn't get through clay but as easy as sand, excuse me. Now, one thing interesting, if you look at maps of historical vegetation in the valley, where you had Tulare Lake, you had these various wetlands, and you have the Sacramento-San Joaquin Delta, which is historically a wetland, you can actually see that same pattern in the soil itself. Where you had the wetlands in the lake, these have more clay material, and they're more poorly drained than the soils that are next to them. And this also translates, even though that natural landscape isn't there, you can also see it echoed in the types of crops that are grown. That where you had the poorly drained soils, these are places that are avoided by people who are planting vineyards and almonds. Vineyards and almonds do better in better drained soils. So where you had those areas of swampy and lake vegetation in the middle of the valley, you have different types of crops than you do on other places. There's a limit in what you can grow there.